Well, this morning we're going to be focusing on software-defined radios, and first up will be John again to talk about how he makes those neat radios he showed us yesterday work. So John, W7FU, come on up and take over.
It might be fully out.
Oh, hello, Shooter.
Hello. Yeah, very good. Thank you. Tom was sort of apologizing a little bit for the weather and the rain and stuff, and I was kidding with a couple people yesterday that I come from Seattle, and this is a drought. So, okay, coping with the light and the screen here, and let me see if I can do this. Okay, there we go. Oh, perfect. Yeah. All right, DSP, remember I said the DSP, the digital signal processing, begins right after the RFIC, the analog RFIC, and the lion's share of the heavy lifting is done in the FPGA, and then this computer, does a lot of the demodulation and radio control functions, bands and stuff like that. So this software loads firmware into the FPGA and has on the computer for the demodulation and things. So today, now, I'm going to try to get this all done in the few minutes that we have. I'll orient you to the programming environment. I have a live demo I made, I'm starring in it, of how to program on the screen. I hope it's coherent for you all. And then I'm going to pull up some real flow graphs that I've made for this purpose and show you what's involved for real radio. And Zach over there and I are going to try and talk on this. This is one of those USRP, SDR radio things across the room here. It works in my shack. Let's see now. There we go. And just, refresher, so many people know this, but not everybody knows it. Microwave SDR hardware, you need DSP software and equals a radio. So how do you convert, and this is kind of cool, I think. Most of us, I can tell by those that some of us don't have hair, some of us, our hair is white. But remember the old days of the block diagrams, analog block diagrams. Well, if you can do a block diagram of a radio, receiver, transmitter, you name it, you can write DSP software using this application. So how do you convert a block diagram to DSP software? You use GNU Radio, and I've heard people talk about it, GNU Radio Companion, which is a portion of GNU Radio that has the graphical interface. Okay. It's free, and for these types of radios, as far as I know, you can't buy software or get something like SDR Sharp on Windows or something. You kind of have to write it in GNU Radio. You can share it, send a file to your friends, and then they could open it up and run it. It's all homebrew, and it requires significant effort. I've kind of put that at the bottom. I should have maybe put it in fine print so as not to scare people, but I've probably, and I'm a slow learner, but I've probably spent a year dinking around with this to get something that works half decently. There's not only manipulating the software, but learning how to do DSP. I do call it, despite what I just said, call it ham-friendly. It's professional and ham-friendly. It's a favorite for professional SDR system developers. They prototype with this sort of thing real quickly, make sure the box works, and then they redo the code in a lower level language, C+ or C or maybe something lower. This software was professionally developed for industrial product development, like I just gave the example. Educational institutions where you teach undergrad and grad students about the mysteries of software-defined radio, and for motivated hobbyists. And I said motivated You got to be motivated. It's open source, free, and it's ham-friendly with the GNU Radio Companion graphical interface. You don't have to write elaborate line code entries. It's based on the library. It's based on the concept of a stored collection of pre-packaged, single-purpose DSP functions, and you can just link them up, maybe like Legos or something, and you come up with a radio, meaning you can get a FM demodulator or a mixer, different filters, different characteristics and things. So you don't have to start from scratch. You just pull one out of the library. It's like going to the library and pulling out a book on a specific topic. Each DSP function is mathematically determined. Everybody kind of knows that in the software. It's these elaborate algorithms that work on the digital signal to make a filter, say. That's all mathematically determined. That's what computers are good for. The graphical interface insulates the user from the mastery of the sophisticated mathematical considerations. The truth is, for me, I don't even know how to look inside of a block deep down where beauty begins. Maybe Zach does, to find out what the mathematical algorithm is. I don't know. So I'm blind. Most users would be blind to the math, just the function. Complete DSP software for any SDR project can be accomplished using the GRC graphical interface. Now, I mean practical radios. There may be some exotic functionality in a radio that I don't understand or don't know about that maybe can't be covered, but they really work at coming up with these crazy library entries. In the proceedings, and I don't think it landed in the proceedings. A number of things didn't land in the proceedings for some reason. But it's on my website, updated, W7FU.com, a step-by-step narrative on how to download and install GNU Radio and how to create a flow graph. Step by step, that's kind of a thing I use, step by step. So there's a revised version. I put that in there revised, thinking it had made to the proceedings, which I don't think it did. There are some flow graph examples that I don't think are in the proceedings, but are on my website. And the actual GRC files for some of these demonstrations that I'm going to try to do this today are there. So what you do on the website, you download them, and then if you have GNU Radio installed in your computer, you open the file and connect it to an SDR like this, and it's doing whatever it was designed to do. These are a reference list, again, on the website, if not in the proceedings. A couple articles from QEX, the classic Lyons books. I mean, some of you must be familiar with him. And he has this incredible library of DSP books starting from the late 90s, and he runs a class in the Bay Area. And he's got this huge book. It's got to be about 1,500 pages now on DSP. And there's my website, bringing up the rear. Live demonstration, GNU Radio now. Let's see. Just have to close this down. And close that down. And the Lord willing, here it comes. Oh, just a second here. For some reason,
You need to select your output source, your computer speaker headphones.
no, excuse me. It's hard to think like this.
I have a Linux expert place.
This is Windows.
Oh, this is Windows? That's Ubuntu desktop.
It's your problem, George.
It's Windows.
Should have put the wheels down first.
Ubuntu desktop. Where's this coming from?
It's a,
VM?
Yeah, VM.
Okay.
I mean, it's a file I made, and it works on my home TV. Come on, take it easy on me. You know, in this situation, things just go blank. I forget my name.
Murphy, yeah.
It plays great on my screen.
Oh, yeah.
Damn.
Yeah, I know it was. Yeah. Yeah, you've only got one audio device shared with your VA, so.
I think we could all hear it.
Yeah, it could be heard.
Oh, oh no.
Give me one of the mics, I'll hold it up to the speaker here.
Yeah, do that. Oh, that's very disappointing. Oh, that sucks. Damn.
I gotta climb and go to the top of 1970.
Okay, let me try one last thing here, and excuse me while I do that, and then I'll give up and just play it and maybe demonstrate on the screen and slink away. Let's try it. This is the live demonstration of GNU Radio. This is the live demonstration of GNU Radio using the GNU Radio Companion graphical user interface. The goal of this video is to demonstrate for you the tools of basic tool competence, that is, the ability to use the GNU Radio Companion, GRC, tool to construct flow graphs and DSPs. Along the way, I'll describe to you the 4 steps of building a successful flow graph and explain this to you as we go along. So starting out, I'm going to move the cursor here in the upper left corner and select the icon of the GNU Radio Companion icon. Right-click the icon, then left-click the text box, and you'll note that the GNU Radio Companion loads. I've had my coffee
with,
this
this
morning.
Big blank space. This big blank space is called the work area. This is the portion of the application where
Okay. I'm going to go direct to GNU Radio and try to repeat some of this just on the screen. And I apologize to everyone. I'm never going to be invited back. Yeah. I'm glad you're enjoying it. So here I'm booting into Ubuntu, and as long as it's somebody else's pain, right? Yeah. Okay. Yeah, just out of curiosity, maybe. Let's see if the video shows up on. Nah, it doesn't. So, let's see. Here are the flow graphs. So here's an audio oscillator. I start out. This is the one I was going to do on the demo. Oh, come on, come up. Yeah, jeez. Okay, I have on my screen what I wanted to show you, but it doesn't project. It does it at home.
It's set for split screen. You got to mirror the 2 screens instead of having them.
duplicate rather than.
Okay. And Zach, if you got any bright ideas, I am not embarrassed to accept help.
Try right. You can never make it work. Try just right clicking on it.
Launcher placement, all displays, normal resolution, sticky edges on scale.
Resolution.
Could that be?
No. Click mirror displays.
Oh, sure.
Yeah. And apply. And we should. Yes, it looks good. Keep. There we go.
Thank you, George. You're a gentleman and a scholar.
I've seen John do this before.
Okay, here is the screen of GNU Radio. I'll just get your basic orientation. This is the library, and you can get some idea. Here's a bunch of filters. I could open it up, and the list will drop down. Math widgets, which means your screen where you control your radio with sliders and buttons and stuff. Modulators and demodulators, FM and stuff. Pagers, peak detectors, resamplers, which are important in managing your sample rates and things like that. And across the very top is a toolbar. And I'll put my arrow particularly across the toolbar. Here you can, maybe the titles will come up. Yeah, create a new flow graph. You can open an existing flow graph. In other words, go into the file system of your computer. Copy, this should read copy, screen capture. Here is this green arrow, which means how you execute a flow graph. And I'm going to do that in a minute here. It's on the screen, and then it compiles it into Python, and then dribbles down through the system to execute the flow graph. This here is a kill button. And here's how you access the library. I'll do that right now. This magnifying glass, just click on it, brings it over here. Oh yeah, thank you very much. Yeah, I see it. Thank you. Is it okay if I walk in front of the screen? No, I don't mind doing that. Yeah. And you notice how this over here. So I'm going to go down and just do filters for fun. See how it opens up, and all these filters open up. DC blocker, FFT filters, bandpass filters. You get the idea. I'm just going to close it to reduce the confusion that I've already created. So here is what's called the work screen. And down here are just monitoring functions which aren't relevant for what we're doing today. Here you can title, it's called options, and maybe I'll open it up. How you open up a block here to find what's inside to a degree is you go to the right click, I right-clicked, I forget, and then you click on properties. And in there, I'll open it up, you can see this is a simple audio oscillator written by me, step-by-step tutorial that's in the webpage, and then different aspects of how this thing runs. The defaults are usually adequate. Just a minute here. Mouse. The next box over is the sample rate. You'll learn about that in the tutorial that it's published. You can see I've been experimenting with the sample rate here for the whole system. 32,000. I tried 512, and I went back to 32. It just played better. These are control blocks. I'll get to those after a minute. And this is, got crunched. This is the flow graph. Here is a simple signal source, an audio signal source I'll turn it on here, open it up to the properties, and you can see that for this signal source, it's emitting floating type signals, and that's, again, something to learn. The sample rate of 32,000, it's a cosine, or it could be a sine, or it could be a square wave or a triangle, whatever you want. Cosine is kind of a default. And the frequency is determined by a control on the screen called audio tone. And here's the output amplitude. And the output amplitude, you can choose between 0 and 1. So then this is a volume control here. It's called a multiply constant. It's under math functions here on the right side. It multiplies the digital signal by some factor to make it louder or weaker. Audio sync is mumbo jumbo talk for a speaker in your computer. And this is an FFT sync, and everyone's kind of familiar with that. It's just an FFT display on the screen. A lot of the parameters here are simple defaults, 10 dB per division, that sort of thing. Okay, so what I'm going to do is turn this puppy on. Well, maybe any questions about the flow of an audio oscillator with an audio tone and a frequency display? Yes, go ahead. Just a minute, I know I hear you. Well, go ahead. Did you want to say? I'm confusing that with my SDR. Ah, thank you for rescuing me because I was thinking of my. This is 12 bits. All right. Okay, it's on, and I'm not sure why the display isn't showing. Oh, there it is. Yes, I'm sorry. There you go. Oh, I know what I ought to do. There you go. And the audio isn't coming through this system, but I'm varying the audio tone up here with this slider. I'm plugged in. Pretty weak. Oh, here, let me crank up the audio. You EME guys. Okay, so this is 3,000. It should be a dog whistle. Okay, so this is an example of how it works. Now, the disappointing stepwise thing is simply because my sample rate is only at 32K. On my radios, I'm sampling at 1 or 2 megs, and it's seamless, it would appear. So that's an audio oscillator. So I'm going to go to this. Any questions at this point? Yes.
You specify the source. The question I have is how do you interface with the sound card? Can you interface with the sound card to say audio in and do something with audio out?
Well, okay, the interface for audio out is pretty much automatic when I choose the correct sample rate. You can see up here. Audio in, that would be an audio source, not an audio sink, yeah. Well, how do I do that? I just link. Well, I do, and I can. It would be a different flow graph where the, like an audio file or something like that would come through.
Yeah, essentially, can you take
I don't know. Okay. Can I talk to my sound card? Yes.
That's what he's doing.
because
It works in both.
Yes, it does.
Microphone input.
that shows up as an audio. So that
What does that mean? I mean, quitting 15?
15 minutes.
Okay, good. Thank you. All right. That's perfect. Just keep reminding me. So, thank you. Maybe we can talk more of the details later. Here is, you can see my file here, an FM receiver, FM transmitter, my transceiver, and an FM simplex multiband transceiver. I'll do the transmitter in the remaining couple minutes here. Yes.
You could take 25.
Well, after this embarrassing start, I just as soon get off the stage as quick as I can. Yeah, where's the hook? That's an honest person. Okay. I don't understand quite when I put this file into this computer, it gets all crunched up, but this is it. So this should be a nice flow graph. Maybe I can make it a little nicer, of an FM transmitter, and Zach and I are going to try to talk across the room here. And let me move this so it's just a little clearer. Okay. This is an FM transmitter. I right-clicked, looked at the properties, NB-FM transmitter, demo for MUD. Here's the sample rate I talked about. This one is 3.2 megs. Here's my controller. It's for transmit and receive, transmit and receive. Then that links here is the sync, the output. This is this box right here, an SDR. It is then driven by a narrowband FM transmit modulator. I threw in some pre-emphasis, not sure why, but I did. And actually what I did is I cut and paste this from my FM repeater rig, and in here I put a subaudible tone, so I have a series of filters that doesn't really need all these. High pass and low pass, so I get a narrow notch for the subaudible source. This is the audio source that we're asking about. This is the microphone. I won't bother with that. The volume control. So what I'm going to do now is go up to the green arrow, compile this, and before long it'll... Yes, go ahead.
Is the user plugged in?
Yeah, it's not plugged in. That's one thing you have to do when you do this. You have to plug in your usurp. And that's, actually a good example of a problem. You notice how when I clicked on this green arrow here, it quickly reverted to red and it wouldn't start. And on the bottom, in this control panel, you can see empty a device address, meaning, as John corrected me, I forgot to plug in the usurp. I'll just start it. The stop arrow is lit, so you know it's loading. This is the very bottom of the screen, the FPGA firmware loading. Just takes a minute. Yeah.
It always does this the first time. It takes longer the first time to run it, plug it in, kind of flash it. Second it goes, it's like. No, it's gotta.
Each time. If you leave it plugged in, there's no problem. Okay, so here is the operating GUI right here. It's abbreviated. And you know what? I'm going to demo what Zach just said. Okay, so I turned it off. I'm going to turn it on. You notice pops right up. So theoretically now I'm transmitting to Zach on, hello, Zach, do you read me? Can you verify? Cross your heart and hope to die?
Yeah, somebody else listen to make sure I'm not. Oh, yeah, here we go.
Testing 1, 2, 3, 4. Whiskey 7, Fox Uniform on FM. Okay, and to illustrate what Zach commented on, I'm going to load another, the receiver file, and this time Zach's going to, here it is, transmit to me, and it loads up real quick, and bam, we're there. Okay, Zach, do your thing. Thank you. Well, it's here. It's just no problem. Okay, so that's the deal. I'm almost done. I'll show you, get wild and crazy. Here is my UHF 9-band transceiver, and that's it. And I have a big screen at home, but and why do I do that? I mean, it's like Topsy. Remember Topsy? What happened? Topsy just grew. She grewed, actually. Well, this is like Topsy. It just grewed. And I'll put this on the screen. So what am I listening to? This is 144.2, which is the calling frequency in Seattle. I don't have the other bands, on this particular screen. It's just too much stuff. Here you can see I have the receive frequency readout. I just click 1296, and suddenly it says 1296. I have a preset frequency where we go off and rag chew off the calling frequency, and there we are, 144.29. I don't know. I can tune this sucker, fine tune. I got all the modulations that I use in this system. Transmit, let's see now, am I going to ruin anything? No. Okay, so theoretically right now I'm transmitting on 144.29, but you're not going to be able to pick it up. So that's that. And let's see here, I'll just do this. This is an FM multiband transceiver. I'll start it right up. Oh, and I should be able to pick you up on this one, Zach. Yeah, try it, see if it comes up. Yeah. Okay. Very good. Thank you very much, Zach. So this is 14658, which we use locally. This is our calling frequencies that we endorse in our area anyway. Okay, and transmit and receive. Yes, go ahead, Zach.
Like something else. So notice I do transmit. Look at where 14652 is. Lot. Testing.
Oh,
So
yeah.
see the carrier there? It's offset a little. Yep. And that's very common with pretty much all SDRs by having the
Exactly. This one's off a few KCs for sure. That's why I put the clock on it. I think I'll quit while I'm ahead. I think I'm ahead. So,
John, you have plenty of time. You want to, why don't we
I'll field questions and, yeah.
make it less time?
Please, yes. Yes.
So, all of these boxes are pre-programmed things and you're just putting them together? Or do you
That's-
have to write some of them?
No. I'll say no. That's the short answer. The long answer is no, no, and no. And I mean to say that the library has all of this functionality already built in. Now, people like Zach, and I will keep focusing on him, they actually can write DSP blocks or modules. I don't.
students I work
More questions? Oh, yeah, yes, and then I'll get you, Andrea.
Is this puppy set up to work, for us cheap hands, is it set up to work with RTL SDR?
Oh, yeah.
Okay.
Yeah. Let me see. Yeah, here it is. Let me blank this out. Let's see, disable, and then enable. And you notice here, oh, that's the RTL SDR right there. Yes. And Lime and the others too. I thought I might have had more time and I could do the but I don't have the RTL with me. But you can see it would this would receive Zach. I have the RTL STR set up to receive Zach, but I just don't have it plugged in. Now, Andrea, you had a question.
Yeah, you had mentioned your 9 bands, but you only had 5 up there. I was just wondering what the other bands were. I just wondering how high in frequency you went.
2304,
5760. I just broke it up to keep the GUI clear. So I have my VHF, UHF, then I have UHF and microwave, and I just toggle between them.
Yeah, I was just wondering how high in frequency.
This box, yes, this box will get to 6 gigahertz. That's a fair question. I mean, please. Yes.
Yeah.
Don't ask me about bit depth or something.
Up. What,
Oh,
as
I'll
far as,
get you there.
far as the computer is concerned, what's the system, how much memory, RAM, that kind of stuff?
Yes. The developers, and I'll stand corrected, the developers recommend an i5 dual core type of box as a minimum to get the full functionality of GNU radio, and that's maybe more functionality than I'm demonstrating today. The memory requirements are, when I monitor my memory, it's sitting there at 2 gigabytes, 2 gigs. But probably, to load things and to get things to run, quickly. I'm running 6 or 8, I think, something like that now. Anybody want to give more advice? I'm running, this is a 7, an old 7.
So if you're looking for 20 megahertz spectrum, 5 band processing, that's what we're, but there are a lot of projects out there. RTL SDR and Raspberry. Your radio running on a Raspberry Pi is installing it like for hours. The file and everything. You can cross the file and look it up that way. Once it's on there, fantastic. Especially the pro.
And Zach isn't joking. A friend of mine did that 24 hours. Even on this box, originally downloading was 5 or 6 hours at times. It takes a while. And then there was a question up in back. Yeah.
Yeah, and I know this is a limitation of the hardware that it's on, but from a hardware perspective, what does the spectral purity look like? You know, receiver dynamic range, receiver blocking spurious, and all that. Has that platform ever been put to the test? And does anybody have any published specs? There's a lot of, SDR radios out there, and they work just fine, but it's hard. RF specs are hard to come by.
Yeah. Now, I saw you had a quick response, so go ahead, please.
That's it, the answer is
Yes, the answer is yes. These have been tested and the results are published, especially for the USRP. Edis Research, and if you, in yesterday's talk by John, he showed some of that in a table.
I was trying to bring that up on the screen. The Edis Corporation, if you go to their website, has some of that data, and the Lime SDR has some of that same data. It's a 12-bit ADD converter, and that they calculate something above 70 dB dynamic range. And the spectral purity, I showed some of that. At the VHF, it's under good. It's so I put low-pass filters in all of my transmitters, and in the microwave region, it's considerably improved with very few or almost none narrowband spurs, and the harmonics are well suppressed. So it's been put to the test, but it depends on the stringency of your tests, I think. And then I was only going to... Okay, go ahead, please. Yeah.
The comment I made, you said you calculated 70 dB. What did they actually measure?
Well, I hear you. Well, they claim in 76 or something. You saw the slide. I can calculate 6 point something times 12 and get 72.
But when you take an ADD converter into the multi-megahertz region, what that simple calculation and reality may not agree.
Oh, I'm sure it's true.
We've
about a dB or so.
we've done a lot of testing, and I've been working with some of the RTLs, and the dynamic range is limited by how many bits you have, and if you've got a 16-bit ADD, you're not going to get 16 real bits. That's right. But there's this magic called decimation, and when you go from 16 bits in a 30 megahertz bandwidth and filter down to 32 kilohertz, you gain a whole bunch of bits, and the dynamic range goes up accordingly. So we look at the HF, like HPSDRs, the Anons and Flex, and the dynamic range is the equal of any traditional receiver and possibly better, because you really get processing gain out of the system.
An increase in effective bits, or is it a reduction of noise band?
I'm not an information theorist, but I think the two are the same.
replacement on TV.
Towards the question where I was asked about the computer, and Zach, my assumption was it's just for radios. So for radios, I can get by with an i5 and not a lot of memory. But Zach was saying, in certain applications where you have higher sample rates and other such functionality, you need, bigger and better computers. So it depends on your use. So for a Raspberry Pi, maybe you can squeak by with a very limited application, yeah.
How do you generate CW in these flow graphs?
Oh, that's a good question. What I do, unfortunately, is I generate a carrier. This is easy to do. And then like in the old days, I remember when I was a kid, I keyed the final amplifier. So I just key my VHF amps and microwave amps, and then a very little back wave. Is that what they do? What were you saying?
You can simulate those.
Yeah, I can cause those.
They make it really sound real.
Actually, on HF, where I operate a lot of CW with my friends who are very, very, very picky, I don't have key clicks that they notice, so it works.
You gotta put some in sometimes with the muscle.
I have enough bad rep right now.
They'll think you got the DX20 back out.
Yeah, DX20. Yeah, God. I remember those. Okay, maybe I should stop unless somebody has any burning questions. Quit making fun of me. Yeah. Okay, I'll step down. Thank you. I just have to unplug everything and I'll get out of the way.